We will now be looking at summative exercises, and the reason for this lesson is basically because geometry is more about practicing than anything else really. Now in this lesson there's not going to be any examples, so the whole thing is just going to be about you doing it. So there's going to be just exercises that you're going to have to pause for every single one, and then try it on your own, and then play it to mark it. Although I'm going to do it slightly differently on the side of where I'm going to give the memo, because with geometry there's basically two aspects of it. The first being, if you look at the problem, you first like take your pencil and you try and figure out, like if you have to find an unknown angle, see what the relationships is of all the angles, and even if you have to try and find just all the angles with your pencil and trying to structure that in your head. And then the second part of it is basically to put it on paper, where it is structured, mathematically correct, where you have your statements and reasons, yeah. So what I'm going to do for the examples or the memos, I'm going to first just talk through the whole thing. So let's say you get to a question you really don't know what to do. Just play it and I will start talking through what to do. Okay, so basically just telling you what the progression of the sum looks like. Then you can pause it again and try and do it on your own. And then after that I will start putting it on paper and actually doing it. Okay, so then also marking your work is very, very important. That's where we look at where we make our mistakes and what we should do next time. All right, so the overview, it's just a total of 10 questions. So the first one, question 1. In the given diagram, A1 is 50 degrees and Y is 50 degrees. So first of all, we're just going to indicate that on the diagram. So we've got 50 degrees and 50 degrees over here. Now, first of all, 1.1, prove that AB is parallel to YZ. Now, when we have the three sets of angles, we've got corresponding angles, co-interior angles, and we've got alternate angles. When we have two angles like these two are corresponding angles, and if they are in corresponding case equal, then it means that the lines AB and YZ must be parallel. So normally we are given that they are parallel, which then tells us, which we can then deduce that the corresponding angles are equal. Now it just works from the other way around. So now we are given that the angles are equal, so therefore we can say that the lines must be parallel. So to write that down, we're going to say, okay, we are given, or we know that angle A1 is equal to Y, or angle Y is equal to 50 degrees, and this is given. Okay, so we can state, okay, the corresponding angles are equal, and therefore AB must be parallel to YZ. Okay, so that's 1.1. Now 1.2, show that triangle XAB is similar to triangle XYZ. Now this is the structure and the format that we do this is like set. So you have you start by obviously saying, okay, I'm working in this triangle and this triangle. Then you list your 3 reasons. And then you end off, therefore this triangle is similar to this triangle. And with similarity, there's always only one reason. It's the 3 angles. So you have to basically prove that the 3 angles are equal to each other. So in the diagram, XAB is the small triangle and XYZ is the big triangle. So we basically have to prove that each corresponding angles are equal to each other. So starting off, we are going to say in triangle, and like I said, this is the same for every time you have to prove similarity or when you have to prove congruency. You start off by saying, okay, I'm working in triangle XAB and triangle XYZ, okay, and then you have to list 3 things, and similarity, it's always the 3 angles. Now first of all, we are given A1 is equal to Y, so that is given. Okay, and then for the second one, we can see that this angle is common, okay, because it belongs to both, so it's obviously going to be the same size, it's the same angle. So it's x, angle x is equal to angle x, and our reason is common. All right. Then for the third one, there's two options. We can either say, okay, B1 is equal to Z because it's also corresponding, therefore they are also equal, whereas AB is parallel to YZ. But what I just normally do is when you have already proven two angles in a triangle equal, the third one would automatically also be equal. So for the reason, okay, so what we're definitely going to say is, okay, B1 is equal to Z. But the difference is you can choose which reason you want to use, whether you want to use corresponding angles or whether you just want to state that the third angle, it's the third angle of triangle. Okay, third angle of triangle. And then we have our three reasons. So therefore, triangle XAB is similar to triangle XYZ. And this part here, this is important that the order is correct. Whereas the first x corresponds to that x. A is equal to y, B is equal to z. That's very important that the order is correct there. And then our reason is three angles, so it's angle, angle, angle. Okay, then for 1.3, I'm just going to start that on a clean page. Now for 1.3 says, hence if xb is 2.5, xz is 7.5, yz is 5.4, calculate AB. Now when you've proven two triangles similar, you can use the proportionality of the sides to find a unknown side, okay? Because the following proportionality would hold. So if we have the smaller triangle side XA and we put that over XY, that ratio will be equal to XB in the smaller triangle over XZ in the bigger triangle, would be equal to AB over YZ. Okay, so you use that those ratios, because the two triangles are in proportion, to solve for the unknown side. Okay, but we are going to start off, because this is now a new question, so we have to state that the two triangles are similar. So we're going to say XAB is similar to triangle XYZ, and we're going to say that it was proven above. All right. Now we can write down the relationships, and the easy way to write it down, and that's why another reason why it's very important that this is in the right order, we can use that smiley face. It's basically just two eyebrows and a smile, so that helps us to remember or to write out the formula. So we're going to say, okay, this one, XA over XY, so we've got XA over XY is equal to AB over YZ is equal to XB over XZ. So this proportion you can, this formula you can deduce from obviously your formula there, or the statement there, or obviously from the diagram where you just look at the proportion, the sides that are in proportion. Okay, so now let's see what is given. We are given XB, so XB we have, XZ we have, and XYZ we have, and it says calculate AB, so this is the one we want. So basically we don't really need to use that. We're just going to work with this side, and we're going to substitute everything that is known and then just solve for the unknown. So we have AB, which we want to solve for. YZ they said is equal to 5.4 equal to XB 2,5 over 7,5. Okay, so solving for AB, we're just going to use cross multiplication, where I'm just going to multiply this 5.4 up, or you can think about just multiplying it both sides. So AB is equal to 2,5 multiplied by 5,4 over 7,5. Okay, and then we just type that into the calculator. 2.5 multiplied by 5.4 all over 7.5. So that is then 9 over 5. Okay, so that is question 1. Now for question 2, this is quite easy actually. So it says determine the size of the interior angles of the parallelogram KLMN with reasons. Now just be careful to read the question properly. So they say we want to determine, or have to determine, the size of the interior angles. That means all the angles A, B, C, and D. Okay. I actually made a mistake once of just calculating x and leaving it there. But first of all, we're going to calculate x. And then once we have x, we substitute it back in to find the interior angles, because that's what the question is asking for. So how do we find x? Now, that comes with knowing the properties of a parallelogram. And if we look at the angles that are given, this is the interior angles, and we know from the properties of a parallelogram that the opposite angles of a parallelogram are equal to each other, which means we can then use that and basically set up a formula where we can solve an equation where we can solve for x. So we're going to say, okay, what do we know? We know that 5x minus 12 equals to 3x plus 18. Okay, and the reason is opposite angles of parallelogram is equal. Okay, and then we solve for x. So 5x minus 3x is equal to 18 plus 12. And then that is 2x is equal to 30, right? Divide both sides by 2, so x is equal to 15. And then we have solved for x. Okay, so now we just need to go further and solve for the interior angles. Let's start with angle A. So angle A is 5x, but now x is 15 minus 12. So we can just substitute that into the calculator, or put that into the calculator. We've got 5 times 15 minus 12. Okay, so this gives us 63 degrees. We know that B is also 63 degrees because of opposite angles of parallelograms are equal. Okay, then for C, now this is obviously parallel because this is a parallelogram, and those two are obviously parallel. So we can choose. Either we want to work with those two angles, or we want to work with those two angles. Let's just work with angle A. Then A, which we know is 63, plus C. What's the relationship between these two? They are co-interior angles, which means they add up to 180. Okay, so that is going to be 180. And then C, okay, this is, let's just say, co-interior angles, and we are using AB is parallel to CD. All right, now C is then 180 minus 63. So 180 minus 60 is 120, so it's 117 degrees. Okay, and then we can just also go further and say, okay, B will be, we used B here. No, this is D, sorry. This is D because this is the opposite angle. So then for B, we can just use the fact that B and C is equal. So B is equal to 117 because opposite angles of parallelogram is equal. Okay, so that was question 2. Now for question 3, PQRS is a kite. A and B are the midpoints of PQ. Now first of all, when you see, like when they say kite, just think for yourself, or maybe just read through all the properties of a kite just to refresh that in your memory. So for example, we know that PQ is equal to PS, and we know that because these adjacent sides are equal to each other. And then the second thing, okay, now carrying on, A and B are the midpoints of PQ and PS. Now, once you see a triangle and they're talking about midpoints on two of these sides, immediately go to midpoint theory, because that's obviously going to be applicable. If you have the midpoint theory says that if you have the midpoint of two sides, okay, and you connect them with a line, that line AB would then always be parallel to the third side, and also it would be half in length to the third side. Okay, so that's already two things that it tells you about that. Okay, then it says QD is equal to DR. So QD is equal to DR. That's just saying the same thing. That's meaning that D is the midpoint of QR, and if SC is equal to CR, it says that it means that C is the midpoint of SR. Okay, and let A be equal to X. Okay, that's all our information. Always be careful to read everything like in this. This is something that I've seen people neglect just too much. And when you start with a geometry sum, just read through it really carefully, making sure that you understand everything that they say there. Okay, and then proof that ABCD is a parallelogram. So ABCD is a parallelogram. So the moment we have to prove any of the quadrilaterals, while you're practicing this, go to the summary and say which lists all the ways that you can prove it. Okay, and then compare which method will be best in this scenario. What information are you given, and with the information that you're given, which method are you going to use? So when we look at parallelograms, the first one is like proving that both pairs of opposite sides are equal. Okay, or the second one, proving that both pairs of opposite sides are parallel. All right. The third one is proving one of the sides both equal and parallel. Okay, and then the fourth one, I think, is that you prove that the diagonals bisect or something, and the fifth one is something else as well. Now, obviously, we have seen with the midpoint theorem, we can both say that AB is parallel to QS, okay, which also means that DC is parallel to QS. So there we can already prove these two parallel to each other because they both parallel to QS. Also, we know that AB is half of QS and DC is half of QS. So we can also say that they are equal to each other because both of them are half of QS. So we're obviously going to go with the third reason by proving one pair of sides both equal and parallel. Okay. Now the other thing, they give us X. Now they don't have to put X there. We can do the whole proof without X, but this is actually going to make our life a bit easier because we can use that in our notation. All right. Now, first of all, I'm going to say, let's focus on AB for now. So we're going to say that that QS is 2x, and all we have to say is that it's the midpoint theorem that states that, because with the midpoint theorem, QS is 2 of AB. All right, and then we can also state that AB is parallel to QS, also the midpoint theorem. Okay, now we've established, okay, QS is 2x. Now we can go on and move to DC. So once we know that QS is 2x, we can say, okay, DC is equal to x because it's half of QS. So we say that because of the midpoint theorem. Okay, and then we can also say that, but DC is parallel to QS, also the midpoint theorem. All right. Now that we've put that down, we can go further and say, okay, but therefore, if DC is x, then it means that DC is equal to AB, okay, and also if AB is parallel to QS and DC is parallel to QS, it means they're both parallel to each other as well. So we can say, and DC is parallel to AB. Okay, so both, now we've basically stated that one pair of opposite sides are equal and parallel. So therefore, A, B, C, D is a parallelogram. and then we've proven it. Okay, now for question 4. Now ABCD is a parallelogram. So let's just pause there. What do we know about a parallelogram? We know that the opposite sides are parallel, so the big quadrilateral, that's the parallelogram. So opposite sides are parallel, and also the opposite sides are equal. So that's equal to that, and that's equal to that. So you usually do that with your pencil just to indicate that, because you might need it later, and you're not gonna like think about all of this when you focused on like one part of the question. So then BE is perpendicular to AC, so this line is perpendicular to AC, so that means that both of these angles are 90 degrees. And also DF is perpendicular to AC, so DF, which makes these two, F1 and F2, perpendicular or 90 degrees for those angles. Okay, now 4.1, prove that triangle FDC is congruent to triangle EBA. Now I hope you know what the structure of this question is. The moment you have to prove similarity or congruency, remember to state in which two triangles you are working, then list 3 things that are equal, and with congruency it can be either sides or angles. Now it has to have at least one side in it. So it can be 3 sides, or it can be one side and 2 angles, etc. Now then once you've done that, just finish off by saying therefore this is going to be this is congruent to that, and give your reasons. Okay, now FDC, which 2 triangles are we working with? We're working with this one over here, and we're working with EBA over here. Now immediately, because I've made those notes, or because I've actually indicated with my pencil what they've told me in the heading, I can actually immediately see things that are equal. We can immediately see that E2 and F2 is equal. We can immediately see that AB is equal to DC. All right. So let's see, and then we just need to find a third thing that's equal. So we can see if these lines are parallel, this actually forms a Z over here. I think if you can see that, which makes C1 equal to A2. Okay, so basically now we've figured it out with pencil and kind of know what to do. So now let's actually just write it down. So we're going to start, so this is 4.1, and we're going to state in triangle FDC and triangle EBA, we have the 3 things 1, 2, and 3. Okay, so the first thing we saw is, and this order doesn't matter. Like now we can choose which one we want to say first. So let's just go with this first angle. F2, angle F2 is equal to E2. Okay, and the reason is given. Okay, they have given to us that the lines are perpendicular. Then we have that DC is equal to AB. This is the opposite angles of parallelogram. Okay, and then finally we know that C1 is equal to A2. All right, and that is because it's alternate angles, and DC is parallel to AB. Right, there's our 3 things. So therefore, triangle FDC is congruent to triangle EBA. What is our reason? Now we can be tempted actually to use that RHS reason, which is right angle, hypotenuse, and side. But the problem is the third one isn't a side. The third one's actually an angle, so it's not that reason. In this case, we basically can just say that we have 2 angles and a side. Now just remember to list them in the right order. So we can either say it's an angle, angle, side, or from this side we can say it's a side, angle, angle. So I'm just going to say the reason angle, angle, side. Okay, so as it is in the diagram, that order you must put it in as the reason. So for example, if we've proven EA equal to CF rather than the other side, we'd have a side between the two angles. Then we'd say it's angle, side, angle. Okay, I hope that makes sense. Now for 4.2, prove that EBFD is a parallelogram. So EBFD is a parallelogram. So like we've done earlier, go to or go through the things that you are able to prove, or which one are you going to use. And from this point, we immediately know that DF is equal to EB because of proving these two triangles congruent. We can then deduce that these two sides will also be equal. Now, can we prove that these two sides are equal? I'm sure we can, but that would be a lot of work, because that would mean you'd have to prove these two triangles, DAE and BCF, first congruent, so meaning doing all of that for the other two triangles, and then saying, okay, therefore DE will be equal to FB. You can do that, but that's a long way. Okay, so let's rather try and prove that these two sides are also parallel, because then we're basically using the third proof, which proves that one pair of opposite sides are equal and parallel. Now, how can we prove that these two are parallel? So if we look at these two angles, these are alternate angles, okay? And these alternate angles are equal to each other. So if these two are equal to each other, it means that these lines that are creating these alternate angles, they must be parallel, because otherwise the two angles won't be equal. Okay, so there's our proof. So the first thing, because it's a new question, I have to state this in my reason. So if it was the same question, you can just say, therefore, you know, DF is equal to EB, and not restate that. But because we are now in a new question, I'm going to say, you can either start by saying that and say therefore, or you can literally just say, okay, DF is equal to EB, but then you must give your reason. And the reason is triangle FDC is congruent to triangle EBA. Okay. All right. Now, for the parallel part, we're going to say that F1 is E1. So angle F1 is equal to angle E1, and that is equal to 90, and that is given. We can say given, or I think more specifically, even at the top here, more specifically would have been perhaps to say that BE is perpendicular to AC and DF is perpendicular to AC. Right. So therefore, if these so we can just then state therefore DF will be parallel to EB, and why? Because the corresponding angles are equal. Not corresponding, sorry, alternate angles are equal. Okay, so that is our reason there. Right, so now we've both shown that DF is equal to EB and that DF is parallel to EB. So we can say, okay, one pair of opposite sides are equal and parallel, which means therefore that EBFD is a parallelogram. All right, and that is it. Now moving on to question 5, PQRS is a parallelogram. So PQRS, so they have indicated that the opposite sides are parallel, and we can also state that the opposite sides are equal. Okay, we know that the opposite angles are equal. If we want to, we can just indicate that like that. yeah, just to make notes for ourselves so that it's immediately evident when we go through our calculations. Right, SR is equal to ST, so that's also already indicated, SR equal to ST. And then P is 120, so this angle is 120. And immediately we can see, oh, that's also going to be 120 then. And then if S2 is equal to 4x, so this is 4x, calculate the value of x. Okay, so in a way, we need to set up a relationship or a equation, kind of, to solve for x using that. Now, if we look at this clearly, we can immediately connect these two together because we know this is also 120. Okay, and then also we can actually calculate this angle. Because this angle is going to be angles on a triangle, so they add up to 180. So we can immediately see, oh, okay, this is going to be 60, right? And this is an isosceles triangle, which means that equal sides equal angles. So this is also going to be 60. And then we can basically use angles of a triangle to solve for 4x, putting that in that equation. Adding them up and equaling them to 180. All right, so let's do that. We've got, first of all, that R1, angle R1 is equal to 120 degrees. Okay, so remember, reason is opposite angles of parallelogram is equal. Okay, next we're going to move over to R2. So my statement, R2 plus 120 equals 180. So this is just basically the relationship. So remember, with geometry, you've got three things that you have to put in. You've got your relationship, you've got your reason, and then you solve. Now this is obviously the relationship, but there's nothing to solve. It's just immediately evident. But now in most cases you write down your relationship, then the reason for it is angles on a straight line. So angles on straight line. Okay, and then you just solve for it. So R2 will then be 180 minus 120, not really needed this step, but then we've got 60. All right, now moving on, we can say that T is equal to 60. And what is my reason? If it's equal sides, equal angles. Okay, in some cases you can say, if the reason isosceles triangle, but according to my understanding, like in grade 12, this is the official reason. All right, so then moving on, now we can put these three angles in a relationship. They're angles of a triangle. So the first one is that 4x plus 60 all add up to 180. That's my relationship. My reason for that is angles of a triangle, and then we just solve for x. So 4x is equal to 180 minus 60 minus 60. So 4x is equal to, so that's 120. So this is going to be 60. Okay, and then divide all. So this is actually not an isosceles triangle. This is actually an equilateral triangle. It just doesn't look like it. So then we divide both sides by 4. We've got x equals to 15. Okay, and always remember, diagrams are really sketched in proportion or accurately. So never go with what it looks like. Always just go with what they tell you, or what you can what they officially tell you. Okay, that's it then. That's solved. So question 6, in the diagram, D is the midpoint of side AB. Already indicated there. And then a triangle ABC, that's the big one. Of triangle ABC, okay. E is the midpoint of AC. Okay, now if we stop there, first of all, we've got this triangle. We are given that these 2 points are the midpoints of the two sides, respectively. So immediately think midpoint theorem, okay? And that tells you that DE is parallel to, will be parallel to BC and also half the length. Okay, so DE is produced to F such that DE is equal to EF, okay? Already indicated. And then we also know that CF is parallel to BA. Okay. 6.1. Write down a reason why triangle ADE is congruent to triangle CFE. Now, in this case, there's no mark allocation in this, and luckily, like in a test, you have that to aid you as well. The mark allocation here would actually just be like 1 mark, because they say just write down the reason, okay? They're not telling you to prove the two triangles congruent, so you don't have to go through all of that structure. They literally only say write down the reason, and the mark allocation will be 1. So that's another indication that you just need to write down the reason, okay? So if we look at triangle ADE, it's going to be this triangle and this triangle, and it's actually immediately evident that we already see, okay, two sides are equal, these two sides are equal, these two sides are equal, and obviously vertically opposite angles are equal. So that's quite easy to see initially. So the reason then is just going to be side angle side, okay, side angle side, because we've got two sides and an interior angle. All right. Now 6.2, again, they say write down the reason why DBCF is a parallelogram. DBCF. Okay. This one is not as this one is not immediately evident like the previous one. So let's look at what we know. We know that these two lines are parallel. We also know that these two lines are parallel. So we can basically say both pairs of opposite sides are parallel. We can do that. So we can say, because we know this because of the midpoint, remember? So let me just make that more clear, otherwise it looks like those. Okay, so 6.2 is both pairs of opposite sides are parallel. Okay. There is another way you can do it, because we already know that this is a parallelogram, right? So that means that this side over here must be equal to DA. So CF must be equal to DA, but DA is equal to BD, which makes, if both BD and CF is equal to DA, it means they're equal to each other. So that's another reason you can use that both pairs, or this one pair of opposite sides, is both equal and parallel. So I think that reason would also have counted, because that you can also prove from this. Okay, now moving on. Hence, prove the theorem which states that DE is half BC. Now, what is that theorem? DE is half BC. Like I've mentioned earlier, the midpoint theorem states that this is half of that. Now, this question is actually structured like it's kind of leading you to do question 6.3, but in the worst case scenario, you can actually be given, like, let me just draw a sketch here. You can actually literally just be given this, A, B, C, this is D and E. So they can give you this, and they can literally tell you to prove the midpoint theorem from this. And the way this is structured, this is literally the steps you have to follow to prove this. But this one's obviously much easier because they're kind of guiding you through. And what would you do? You'd basically extend this DE line in the same length, and then you would create a parallelogram over here like that. So this would be equal. So you'll basically make this construction, and then you'll basically first prove that these two angles are congruent, all right? And then you'll prove that this is a parallelogram, that DBCF is a parallelogram. That's the second step. And then the final step is just to, using this, you will then continue or just complete the proof. Okay, and to do that, we basically just need to prove that DE is half BC. And with this knowledge, we can say that because this is equal to this. Now, normally the reason you'll say is because we've just seen that this is a parallelogram, we know that the diagonals of a parallelogram bisect. But in this question specifically, you are already given that it is, because this question is kind of a lot easier. They give you information, whereas in if they just give you this, and this proof is actually in your textbook, okay, or it should be, where the midpoint theorem section is, this proof should be there, okay. So basically, to start off, we can say that DE is equal to EF, and in this question specifically, we can just say that it's given, okay. And then we can say, but DF is equal to BC, because that's the opposite sides of a parallelogram. Now, if DE is the half of DF, but DF is equal to BC, then DE must be the half of BC. Okay, so let's just write that down. So we'll say that DE is equal to EF, and that is given. Okay, and therefore DE must be equal to half of DF. This entire, if this is equal to this, it means that is half of that. But we also know that DF is equal to BC. And if DF is equal to BC and DE is half of DF, it means that DE will be also half of BC. Okay, so that was quite a lot, I think, just to wrap your head around that. But what I would recommend is like just learning that proof off by heart, because I think they can ask it in an exam. Not a regular question, but it's possible. Okay, so now for question 7. In the diagram, PQRS, so PQRS is a parallelogram having diagonals PR and QS intersecting at M. B is a point on PQ, so B is a point on PQ, such that SBA, so SBA and RQA, or where are you? RQA, these are straight lines, and SB is BA. SB, so let's just indicate that SB is BA, so these two lines are equal. SA cuts PR, SA cuts PR at C, and PA is drawn, so PA is just connecting those. So 7.1, prove that SB is QA. SB is QA. Now we are given, what are we given? We are given that this is a parallelogram, so meaning that these two sides are equal to each other, okay. Then what else? So this is not given that it's like the midpoint or anything, because my initial thought is if we can prove that like these two are equal, or given that these two are equal, and also we know that these opposite sides are equal, then if both of this side and this side equals to RQ, then they are obviously equal to each other. But I can't see anything like that. So I'm just trying to like kind of speak about how I think about, or what I'm thinking. Okay, so then next thing, let's look at normally if we have to try and prove, or have to prove two sides equal, the next thing we can actually look at is if we can prove two triangles congruent, then obviously any corresponding sides would also be equal. So can we identify any two triangles? We can see that we've got SBP and we've got ABQ. These two are triangles, and their corresponding sides are SB and QA. So if we can prove these two to be congruent, then basically we can say, okay, therefore these two sides would be equal. and there is already something we can use. We can say that SB is equal to BA. So I think we are going to go with that. Also, we know that the vertically opposite angles are equal. And then we also know that these two lines are parallel, which means let's look for like alternate angles. So we've got alternate angles running over there. So this angle basically is equal to this angle because SP is parallel to QA. Okay, so there we have it. Now, first of all, we're just going to go through the whole structure of proving these two triangles congruent. Then we're just going to say, therefore, these two corresponding sides are equal. Okay, so 7.1, I'm going to say in triangle SBP. Okay, so, and triangle. Now, this isn't like that important, but I would like to basically just start off and putting it in the right order. Not at this stage really like you have to. It's when you end up with it that it has to be in the right order, but I just like to start off with it being the right order anyway. So if we have SBP, then this angle, which corresponds to S, is ABQ. So ABQ. So in those two triangles. So the three things we're going to prove are, first of all, what is given, SB. SB is equal to BA. That was given to us. Okay. Next, we can see that SBP, that angle, is equal to ABQ. And that is vertically opposite angles. And finally, we saw that PSB is equal to BAQ. And the reason is alternate angles, whereas SP is parallel to QA. Okay. Now we can say, therefore, triangle SBP is congruent to triangle ABQ. Now our reason is we've got an angle, side, and angle. Okay, so that's angle, side, angle. And therefore SP is equal to QA. Okay, that is done. Now moving on to 7.2, prove that SPAQ is a parallelogram. SPAQ. That's very easy. Why? Because we've just proven that this opposite sides are equal, and we already know that these opposite sides are also parallel. So there it is. Like, just state that and say, therefore, one pair of opposite sides are equal and parallel, so therefore SPAQ or SPAQ is a parallelogram. So 7.2, so we're going to say that SP equals to QA and state that it was proven above. Okay, then we know that SP is parallel to QA. That is basically given, okay, because it's given that this is a straight line, remember, but it's also given that that and that is parallel. And then we can say, therefore, or we can just state one pair of opposite sides equal and parallel, okay, and therefore SPAQ is a parallelogram. Okay, done. Now finally 7.3. So let's just start by clearing the page. And we need to prove that AR is 4 times BM. Now this isn't like a very easy question, if I can state it that way. We kind of have to try and relate this side to this side. And at this point, it doesn't seem like they have any direct relationship. We do know that AR has a relationship to SP because AQ is equal to QR, and that's equal to SP. So basically we know that AR is twice SP's size. Okay, that's our first thing. And then how are we going to relate SP to BM or MB? Now, first of all, we are going to have to look at if we can show that this is the midpoint of SQ and that B is the midpoint of PQ, you've basically got a triangle, and you can use midpoint theorem, which says that BM will be half of SP. And is there a way to do that? There is, because this line is the diagonal of this parallelogram. And we know that the diagonals bisect each other, which means they cut each other in half. Okay? And also, we know now that this is a parallelogram. We've just proven that. And this line, PQ, is the diagonal for the parallelogram, SPAQ. Okay, and once again, the diagonals bisect, so meaning that B is the midpoint of PQ. Okay, then we can say that BM is half of that, and that is half of that, and then or just manipulate those to form this proof. Okay, so now to put it on paper, 7.3. So I'm going to start off by saying that RQ is equal to SP, so RQ is equal to SP opposite sides of parallelogram is equal. And then I'm going to say that QA is also equal to SP, same reason, opposite sides of parallelogram is equal. Right, now we can say therefore RA or RQ is equal to QA, and therefore AR, AR is twice SP. Okay, now moving on to the next one, let's first start by saying that SM is equal to MQ because the diagonals of parallelogram bisect. Okay, so therefore M is the midpoint of SQ. And similarly, PB is equal to BQ, diagonals of parallelogram bisect, right? So therefore B is the midpoint of PQ. Okay, so now we can basically use the midpoint theorem and say, okay, that MB is half, or actually let's write it the other way around. Let's rather write that SP is 2 times MB. Okay, and our reason is just simply midpoint theorem, which states that this would now be half of that. And then finally, we've got these two relationships. We've got that AR is 2 times SP, but we've got SP is 2 times MB. So I can take this value for SP and substitute it in for this value for SP. So I'm going to say, okay, AR is equal to, so that 2 over there. And then instead of saying SP, I'm going to say 2MB. So 2MB. And then if we simplify that, we get our proof. So AR is 4MB. Okay, question 8. KLMN is a rhombus with diagonals intersecting at O. So once again, what is a rhombus? A rhombus is both pairs of opposite sides are parallel. So it's basically a parallelogram, except all four sides are equal in length. Okay. Now next, LKM is 34 degrees, and question 8.1 says write down the size of O1. Now this is nothing you need to calculate. This is a theory question, because what do we know about a rhombus? The diagonals of a rhombus they do bisect, but they also bisect perpendicularly, which means all four of these angles are 90 degrees. Okay, so for 8.1, we know that angle O1 is equal to 90 degrees. That's basically like 3 marks, I think. Then 8.2, calculate the size of L1. Now, we can see that these three angles form a triangle. They are the angles of a triangle. So very easy to find L1. We can just say all three of them add up to 180, angles of a triangle, and solve. So I'm going to say L1 plus 90 degrees plus 34 degrees is equal to 180, and the reason is angles of a triangle, and then just solve. So L1 is 180 degrees minus 90 minus 34. Okay, so this is 90 minus 30 gives us 60, minus another 4 is 56. So this is 56 degrees. Okay, next 8.3, calculate the size of K in M. So K in M, this means this is this entire angle over here. All right, now what we can do is we can calculate the two smaller angles, adjacent angles, separately, and then just add them together. Now let's start with N1. First thing we can see is there's this triangle over here, okay, and this triangle would obviously be an isosceles triangle because all four sides are equal. So that means that these two angles are equal to each other, which means it's equal to L1. Okay, so N1 is equal to L1. Then to find N2, there's two ways. All right. The one way, we can also say that it's equal to L1 because they form alternate angles. All right. But also another property of a rhombus is that the diagonals bisect the angles, which means these two angles will be equal. Okay, so you can use one of those two reasons, basically. So let's start with N1, 8.3. So N1 is equal to 56, and it is equal sides, equal angles. Okay, done. Then N2 is also equal to L1, so N2 is equal to 56. So either the reason that diagonals bisect the angles, or you can just say alternate angles. I'm just going to say alternate angles, whereas KL is perpendicular to NM. Okay, now we can say that therefore K and M is equal to 56 plus 56, and that's going to be 112 degrees, and we are done. Okay, question 9. In the diagram, ABCD is a parallelogram with diagonals intersecting at E. So ABCD, parallelogram, diagonals intersecting at E. The diagonals of parallelogram DECF intersect at G, and the diagonals of parallelogram FGCH intersect at K. So we basically have three separate parallelograms, but they are kind of joined together, whereas the half of the diagonal of the biggest one forms the side of the one smaller to it, and the same, whereas this side forms the entire diagonal of the smallest parallelogram. Now we need to prove that DB is 4KC. Now DB is the diagonal of the biggest parallelogram, and KC is half of the diagonal of the smallest parallelogram. And the relationships that are formed here are, like I said, we can know that this dB, DE is half of dB because basically the diagonals bisect, but DE is also equal to FC because opposite sides of the parallelograms are equal. But we also know that KC is half of FC, which makes KC half of DE, because of diagonals bisecting and opposite sides equaling. Okay, so that's basically the relationships. Now the other problem is putting it on paper. Okay, so starting off, we can basically say, so in our proof we want to start with dB. So we want dB in there. So let's start and say, what is dB? dB is half of or two times dE. But before we can say that, we just have to start and say, okay, but dE is equal to EB because of diagonals bisect, diagonals of parallelogram bisect. Okay, and then we can state, okay, but therefore dB will be equal to 2 times dE. Okay, right. Now moving on, we need to take dE and kind of relate it to KC. So first of all, we can say that dE is equal to FC. So dE is equal to FC, and our reason is that opposite sides of parallelogram is equal. Okay, now FC and KC. KC we know is equal to FK. So let's write that. Let's say FK is equal to KC because the diagonals of a parallelogram bisect. Okay, so therefore FC is twice KC. Okay, now we basically literally just said all our relationships. Okay, now we can just use this relationship, and this relationship. We're basically going to just substitute in the relationships into each other. We're going to say that dB, we could have actually said it here, because if dE is equal to FC, that means that dB is equal to also 2 of FC. Okay, and then we know that FC is 2 KC. So in this relationship over here, I'm going to use, and this relationship over here, I'm going to use, and dB, and instead of saying FC, I'm going to say 2 KC because it's equal to that. So dB is equal to 2, which is that 2, and then substitute FC, going to substitute 2 KC, and therefore dB is equal to 4 KC, and we've proven what we wanted to. Final question, question 10. Triangle ABC is a right angle at B, and then F and G are the midpoints. So F is the midpoint of AC, and G is the midpoint of BC. H is the midpoint of AG, and E lies on AB such that FHE is a straight line. Right, just that meaning that, first of all, we can see like the midpoint theorem playing a role here because we've got like 2 triangles here. We've got this smaller one, actually got 3, but we've got this one on the right hand side, CGA, and immediately we can see that the midpoint theorem plays a role. We know that HF is parallel to GC and also half of it. And the fact that they say FHE forms a straight line, because we're going to use that, because if these 2 lines are parallel, HF and GC, it would also mean that EF must be parallel to BC. Okay, just extending those lines along there. Okay, 10.1. Prove that E is the midpoint of of AB. Now, with the midpoint theorem, in the question so far, we've only used it from the one side. It actually also goes both ways. The one side is if you're given, that these two are the midpoints, then you deduce two things. It's half the length and parallel. Okay, so that's the one side. Or you can be given one of the points are a midpoint, but also that the lines are parallel. Okay, so if you're given those two pieces of information, what can you deduce? You can then deduce that this HF will be half of that, and also that H will be a midpoint to that line. So we are first going to work from the one side in this triangle, and then with the knowledge of being parallel and only knowing that H is the midpoint, we are going to deduce it from the other side that E is there for the midpoint of AB. Okay, so let's start doing that. So 10.1, first of all, we have that HF is parallel to GC, and we're simply going to say that's because of the midpoint theorem. Okay, then we're going to say therefore HE will be parallel to GB. Okay. Next, we can just state that H is the midpoint of AG. That is given. Right. Now we have this information that these lines are parallel. We have this piece of information that this is the middle point. Now what can we deduce from that? We can say therefore E is the midpoint of AB, with our reason being midpoint theorem. Just to make this a bit clearer, that's the reasons. Okay, yes, that's done. 10.2. Now the rest of this is calculations. If EH is 3,5 centimeters, and the area of triangle AEH, so AEH is this smaller one, if that area is 9 centimeters squared, calculate the length of AB. Okay, now AB is this big length, all right? So what can we do? We can focus on the smaller triangle and just calculate the length, because that's the perpendicular height of this triangle. And then we know if E is the midpoint, that AB will be just double EA. All right. So let's do that. Now, normally, obviously, when we work with areas, we're given like the base and the perpendicular height, and we just substitute it in the formula, and that gives us the area. In this case, we are given the area, but one of the sides we do not know. Now, basically, what we're going to do is we're going to write down the formula for the area of a triangle. So area of triangle, which one? AEH is equal to half base times perpendicular height. But in our case, the base is EH, okay, times by the perpendicular height, and the perpendicular height is EA. Now substitute everything that you know. Area of triangle AEH is 9 and half, so EH is 3,5, so times 3,5 times by the one we want to solve EA. Okay, so everything's known except for this. So now we're just going to solve for EA. So EA is 9 over, I'm just going to take all of this, divide it both sides. So 9 over a half times 3,5. And we can put that into the calculator. So we've got fraction 9 over, now I'm just going to write 0,5 instead of a half, times by 3.5, and that is equal to 36 over 7. Okay, and therefore the length of AB will just be 2 times 36 over 7, and we can just take our answer and multiply it by 2. That gives us 72 72/7. And our units is in centimeters, so centimeters. Right, now the final question, hence calculate the area of triangle ABC. So ABC. We just saw that this is, what was that length there? Just go back, 72/7. Let's just indicate that here. So 72/7. Now, if this is 3,5, then that would be twice 3,5, so that would be 7. And this is 7, this is 7, so this whole length over here must be 14. So to calculate the biggest, the triangle ABC will be quite easy. We know the base, know the perpendicular height, we can just use the formula. Okay, but let's just write that down. So we've got 10.3, and first of all we're going to say that BG is equal to 7, because that is according to the midpoint theorem. Okay, and we know that GC is 7 given, okay, and therefore BC is equal to 14 centimeters. All right, now the area of triangle ABC is equal to half the base, and the base is BC multiplied by the perpendicular height, which is AB. Okay, so we've got half times BC is 14 multiplied by AB, which is 72/7, and then if we put that on the calculator, 0.5 times 14 times 72/7, that gives us 72. And our units are centimeters squared. Right, so that was all of the 10 questions, and then we are done.